Now we're going to try to solve an equation that's a fourth degree polynomial. Now notice this isn't a polynomial function. If it were, I would have wrote f of x. But it is a polynomial. And because of that, its solutions are called roots. If it was a function, its solutions are called zeros. Just a little bit of a bonus for you on Jeopardy. So how do we solve this one? We go through the same process we've done before. Let's see if we can kind of narrow the search of rational roots by looking at the ratio of the constant over the leading coefficient. So I'm going to compare the 24, the factors of 24 with the factors of this 1. 24, my favorite number, because it's so cool, has so many factors. In this particular case, not my favorite number because it has so many factors. So, all the possibilities, plus or minus 1, plus or minus 2. All right, there's my entire list of possible rational solutions. I have 1, 2, 3, 4, 5, 6, 7, 8 pairs, 16 possible solutions. Again, I know there's 16. That does seem like a lot, but that's a lot fewer than the entire numbers on the number line. So always think of it in terms of that. So now we go through and try to figure out which are the solutions so that maybe we can throw out, or maybe a factor will get tossed out. I'm going to try 2. And then use synthetic division. 1. Oh, notice there's no x cubed term. So I need to make sure I put a 0 placeholder when I write my synthetic division out. The squareds minus the linears and the constants. 1 drops. 2 times 1 is a 2. Makes it a 2. 4. Negative 2, negative 4, negative 12, negative 24, and it produces a 0 right there. So I found out that 2 is a solution, which means that x minus 2 is a factor. That's good. So then what I can do is I can rewrite my original expression as a factor of x minus 2 times what this embedded result means. This first term is an x cubed plus a 2x squared minus a 2x minus a 12 equals 0. All right, step 1 is done. Notice then that my resulting group of terms there is now a third degree. It doesn't factor, so what I'll do is I'll go through this process again. Let's look at all of, so I want to solve, or look at this one right now. Let's narrow its search down for possible rational zeros. And we notice that it just is, again, all of these except, whoop, nope, it's not all of those. So let's go through. I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. All over the leading coefficient, which was a 1, plus or minus 1. So I was checking those two numbers right there, kind of just starting the process again. Let's find out which one of these is the possible rational root. Felt lucky on 2 last time. Let's do 2 again. And its numbers are, I have a 1 in the x cubes, 2 in the squares, negative 2 in the linear, and negative 12. In the constant place, drop the 1, 2, 4, 8, makes that a 6, 2 times, look at that. Winner. Got a 0 as a remainder, which tells me that 2 is a solution, which means that x minus 2 is also a factor. All right, I'm liking this. So how do I take that result? Here's where I started. Here's my next step. Then what I can do is add this factor. So I have x minus 2 which I got the first time. The second one, I found another x minus 2. And then what's left is embedded right here. That tells me then I have an x squared plus 4 plus a 6, all equals 0. All right, notice how I went from a 4th degree issue to a 3rd degree issue. Now I'm at a 2nd degree issue. So let's look at this last term right here and see if that will factor or solve. It doesn't factor. I can't factor it cleanly. So let's go to quadratic. That being the case, my A is 1, my B is a 4, my C is a 6. Don't feel bad. Use paper on these problems. So to solve that then, minus B plus or minus B squared minus 4 times A times C, which is a 24, all over 2 times A. That reduces down to a minus 4 plus or minus a negative 8 all over a 2. Negative 4 plus or minus a 2 pops out. I'm left with a root 2 I all over a 2. I can factor a 2 out everywhere. So I have a negative 2 plus or minus root 2 I. And there's my next two solutions. This produces a solution of x equals, oops, sorry, not x. Well, yeah, x equals those, or it produces a factor. That's what I want to mean. Well, let's do my two factors. So one solution of x is minus 2 plus root 2i, and the other solution is x equals minus 2 minus root 2i. And there's my 4 solutions. I have 4 solutions to this particular equation. I have a 2 as a solution, another 2 as a solution, 4 solutions. Now there's a couple of things as we work through this I want you to notice, and maybe you've already observed as we've gone on. All right, how many different solutions to this problem I have? I have 4 solutions, if we count the 2 independently of each other with multiplicity 2. So there's 4 solutions there. Is there any coincidence that there's 4 solutions and that my leading index or my leading exponent of my original equation is a 4? There's a relationship between that number and the total number of complex roots I could find. That's kind of where the fundamental theorem of algebra will kick in. Second thing I want you to notice is that I had a complex root. Anytime I have one root that's complex, that means that there's another root, its conjugate will be there. Conjugate solutions always form. So if one's a solution, you know its conjugate pair will also be a solution. So those are 2 additional things that I want us to be aware of as we solve this problem moving forward. Look at the relationship to this root or this exponent for the total number of solutions, not always the total number of rational solutions, the total number of complex solutions. Now, complex solutions are not just imaginary solutions. Remember, a complex number had an a plus a bi, and that meant that b could be 0, so a complex number could have just been the a, or a complex number could have been just the imaginary part, or it could have had a combination of both. So the point that we have here is that we are going to have, on this particular problem, 4 complex roots. Some might be imaginary, some might be real, some might be a combination of those, but there's going to be 4 that we're going to look for.